Chapter 12 finishes on a topic that is frequently not even taught in a standard geometry class, but conic sections are treated in Algebra 2 algebraically, and it makes perfect sense to introduce them here geometrically first. So this is an excellent chapter, even if you might consider it optional in some respects. It's definitely worth spending the time on. A conic section, one way to look at it is it's what you get when you intersect a plane with a cone. If you intersect it in this way, what you have here is an ellipse. If the plane goes so it cuts through both parts of the cone, you'll have a curve that has two branches to it, and this is called a hyperbola. Even though it looks like it's two separate curves, it's considered all one curve. They have the same properties, they're symmetric. Even if the plane isn't purely vertical, the two curves will be symmetric with respect to each other. If the plane that you intersect is parallel to one of the edges like this, it'll only have a single branch, and this is a parabola. This goes forever. It doesn't exit the cone somewhere down the line, but that's the distinction between a parabola and a hyperbola. One of the remarkable properties of an ellipse is if you have a room that's shaped like an ellipse, there are 2 points that are special that are called the focal points, or foci. That's the plural for focus. If you were to stand at one focus and your friend stood at the other, and you speak just in a whisper, your voice goes out in all directions. And when it hits the walls, it would reflect at equal angles and go directly to the other focus. So even whispering in a large room like this, the other person would have the sense that the voice is in their head. All that sound would become focus. The interesting thing is all of the conic sections have focal properties that are analogous to this. You may have constructed ellipses before. If you haven't, it's worth doing with pencil and paper. Here's a simulation using GeoGebra. But basically, if you have 2 pins and a string, and you move the pencil so that you keep the string tension there the whole time, what you get is your ellipse, and the 2 pin locations become your foci, or your focal points. Here we have the focal property of a parabola. A parabola has a special point called the focus, and any ray that comes out from that focus to any point on the parabola would be reflected at equal angles from a tangent line so that it goes out parallel with the axis. Many people aren't even aware of the focal property of a hyperbola, but if you were to take a ray that comes from one focus and goes to any point on the hyperbola, whether it's the near curve or the far curve, it would reflect directly away from the other focus. Typically, in an Algebra 2 or pre-calculus class, you'll use the definitions of these conic sections, like in this case we're talking about a parabola, and applying the definitions using coordinate techniques, you can come up with an equation for these curves. This text does that for a parabola, which is the simplest case, and you can do similar kinds of things with ellipses and hyperbolas. That's not handled in this textbook, but that's something you would get to in Algebra 2. All in all, this chapter, even though it is somewhat of an optional chapter, is a great way to round out the course. And I highly recommend that you go all the way through it and not cut short. 2.5 weeks is probably sufficient for this, although this is going to be the end of your school year, and so you can take whatever time you have available and take whatever pace is comfortable for you. Okay.